Hi guys, welcome back to Agriculture Science with Mr. Jackson. Today our objectives are 1. Arrange data using Microsoft Excel. 2. Create a graph from a data sheet using Microsoft Excel. 3. Transfer graphs from Microsoft Excel to Microsoft Word. And 4. Interpret the graphs created. In today's lesson, we'll be looking at data collection and results. The CSEC Agriculture Science SBA requires students to conduct a research project. An important aspect of the research project is the methodology. This lesson does not cover in detail every aspect of the methodology. However, there is one particular aspect I would like to address. This aspect is known as the data collection parameters. In each experimental trial, a minimum of 2 relevant data must be measured and data collected. In this example, a crop of sweet peppers will be examined to determine the best fertilizer treatment for optimum yield. As such, the 2 relevant parameters are the average height of plants and the total yield of sweet peppers per treatment. This experiment has 3 treatments. 1. A control group. 2. An inorganic fertilizer group. And 3. An organic manure group. Data for the 2 parameters will be collected from a representative sample for each treatment. Let's take a look at the spreadsheet containing the data that was collected for both parameters using Microsoft Excel. The table displayed shows the raw entries of data that was collected for 3 out of the 5 months of data to be collected. Only the first 3 months of data collection was shown, mainly for demonstration purposes. The table consists of a title, a sample size of 10 plants from a total of 20 plants per treatment, the collection of data per treatment for each month, and the averages per treatment for each month. It is important to calculate the averages so that the data that was collected can be summarized for ease of understanding and interpreting the information. The average can be derived by first selecting the group of data entries. Located on your toolbar, click the down arrow located next to the sum function icon and select the averages. Excel will then compute the average for the numbers that was selected. Using the averages per treatment for each month, a more concise table can be formulated. Apart from summarizing the data for ease of understanding, the summarized data entries can be then used to formulate a graph to better depict what the numbers in the table represent. In this case, a bar graph will be used because bar graphs are used to compare different categories of data. To formulate a graph using Excel, there are a few steps you need to follow. Step 1, we need to select the headings and averages per month for each treatment. Step 2, on your toolbar, select Insert, Chart, Column, and Clustered Column. A basic bar graph should then be displayed on your screen. There are a few common requirements of a graph for it to be deemed a suitable graph. It must have a title, labeled axes, a legend, to differentiate between different treatments, and data labels to show the value of each bar represented in the graph. Step 3. Once the basic graph has been formed, we will then add a chart title by clicking Chart Layout and select the option Chart Title above Graph. A text box with the words Chart Title will appear. Simply click on the text box and add your chart title. Step 4. Adding both a horizontal and vertical axis. On your toolbar, select Chart Layout, then Axis Title. Select Horizontal Axis Title, then choose the option of Title below Axis. For the Y-axis, select Vertical Axis and then choose the option Vertical Title. Step 5. On your toolbar, select Chart Layout, Data Labels, then choose the option Outside End. It is important to note that the color of each treatment can be customized by simply selecting the bar which represents the particular treatment that you wish to change. Then on your toolbar, select Home. This will allow you to select the color fill icon that resembles a paint pan. Click the down arrow and you will now be able to select a color of your choice. Here you can see that the colors for the control group was changed. Let's now label the axes. The x-axis represents the total amount of months in which the experiment was conducted. And the y-axis represents the height in inches for each treatment that was measured. The same can be done for the second set of treatments. First, let's highlight the area which we want to use to formulate the graphs. Then we click on Insert, Charts, Column, Clustered Column. There is a shorter way of formulating the items required for a graph. Click by selecting Layout number 9 in your chart layout. All of the following items of a chart will be provided: the chart title, the X and Y axes, and the legend. If you look closely, all the colors for each treatment is the same. This is not recommended. So, to change this, You click on Home, select the particular treatment you would want to change, click on the color fill icon down arrow and choose a color of your choice. You can do this for the other two treatments as well. Now let's add the chart title. Now let's label the x-axis. The x-axis in this case represents the treatments based on our experimental design. And on your y-axis, these numbers represent the weight in pounds. Last but not least, we now will add the data labels to represent the value of each bar per treatment. Click on Chart Layout, Data Labels, and select Outside End. To use these graphs in your Microsoft Word document, you simply copy, then paste these figures into your Word document. For each table, there must be a figure to go hand in hand as required in the syllabus for the school-based assessment projects. Graphs can be copied from Microsoft Excel into Microsoft Word where your SBA is being typed. For each parameter outlined in the methodology, there must be corresponding tables and charts. As mentioned earlier, a minimum of 2 parameters are required. Each table must be itemized. For example, Table 1 and Table 2, Figure 1 and Figure 2. Note that the tables are itemized above and the figures are itemized below. In Table 1, we can see the average height in inches of sweet peppers for months 1, 2, 3, 4, and 5. Table 1 shows the average height in inches of sweet pepper plants in each treatment for a period of 5 months. A ruler was used to take the measurement in inches of the 10 random plants as a sample for treatment for each month. This data was collected once per month. Table 2. Table 2 shows the total weight of sweet peppers for each treatment. Peppers were harvested for each treatment for 2 months, and the yield relative to each treatment was measured using a scale and then recorded. Now let's take a look at the results section. Table 1 should mirror what Figure 1 displays. Here we have our graphs that were formulated in Excel and copied and pasted into Microsoft Word. Figure 1 shows the average height of sweet peppers per treatment for a duration of 5 months. Sweet peppers that were fertilized using an inorganic fertilizer, 16-8-24 plus 2, had a higher average height relative to the other 2 treatments. organic manure and the control group. On average, sweet peppers that were fertilized with the inorganic fertilizer had a difference of 6.4 inches in height than those of the control group and a difference of 6.3 inches relative to the sweet peppers that were fertilized with the inorganic manure. As such, there is a considerable difference in the height between each treatment. Now let's look at figure 2. As mentioned before, figure 2 should mirror what table 2 shows. Figure 2 shows the total weight of sweet peppers per treatment. Sweet peppers that were fertilized using an inorganic fertilizer performed better than the other two treatments in the trial. In comparison, sweet peppers treated with an inorganic fertilizer produce 8 more pounds than those that were fertilized using an organic manure, and 12 pounds than those of the control group. As such, there was a considerable difference in the total yield between each treatment. Now, let's take a closer look at the marking scheme. The section Data Collection consists of a total of 4 marks. To obtain these marks, the student must present a minimum of 3 pictures engaged in 3 different activities. Each picture must have a brief description of the type of activity he or she is doing. In addition, students are required to have displayed 2 tables consisting of summarized information relative to the parameters outlined in the methodology. Proper units of measurement, itemization of table at the top of each table, a brief description of what the table shows, and how the data was collected are all required. Now, let's look at a breakdown of the results section of the SBA. A total of 8 marks can be obtained in this section. Students should strive to do their best to maximize the amount of marks they obtain. The marks are broken down as follows. 2 marks are awarded if students did in fact collect relevant data. In our example, the collection of the number of sweet pepper leaves would not be considered as a relevant data, simply because the aim of this trial focuses primarily on the differences in yield between treatments. Another 2 marks is awarded if students present figures that consist of the chart title, labeled axes, the legend, correct units of measurement, and data labels. The majority of marks, however, is obtained if students provide a full interpretation of the figures they present. A full interpretation includes the following. 1. Stating what the figure shows. 2. Providing a brief description based on the general observations of the graph. Did treatment A performed better than treatment B? 3. Comparing each treatment by stating the calculated difference between each treatment. And 4. Stating whether or not there was a considerable difference between each treatment. The term "a significant difference" is not used simply because no statistical test was done. If this information was useful to you, please like and subscribe and share it with your friends. See you guys next time.